Ladies and gentlemen, the e-seminar is starting. Lenny, please go ahead.
Thanks so much, and welcome everybody. Glad you could join us today for this really important webinar on the many flavors of NoSQL, helping you with how to choose the right technologies for your next great app. Obviously, this is a very important issue for all of us who are trying to do more with data, do it more quickly, do it more efficiently, do it in ways that more adaptively deliver value to the business. So glad you're with us. I am going to make a few logistical announcements before we get started. First of all, I want to let you know that you have an opportunity in the next hour or so to access a tremendous subject matter expert absolutely free. So I encourage you to use the console. You should see it in front of you to submit a question at any time. Just type your question into the Ask a Question area and make sure you click Submit. Now, we'll be doing Q&A at the end of the presentation, but please, you don't have to wait until then to submit a question. If Mike says anything at any time that you want him to elaborate on, or even if you want to challenge it, go ahead and send us a question so that this is nice and interactive. If you'd like a PDF copy of today's presentation, you can download that. You see the resources folder. You can also, by the way, the slides will advance for you automatically. If you have any technical questions or issues while we're doing the presentation, again, just use the Ask a Question area, and we'll be glad to give you some individual assistance. So I do want to tell you about Mike Rio, who is a solution engineer with IBM's Worldwide Analytic Platform Services. So Mike's been working with distributed databases with a focus on NoSQL databases for his whole professional career. He was involved with HBase Hadoop as part of the Big Data Stampede team. He's been involved with helping organizations onboard Big Insights, which is IBM's Hadoop platform, and everything that includes. He was part of CloudDB. As a matter of fact, he's got a real wealth of experience with all kinds of solutions, including CloudDB and MongoDB and Elasticsearch and also Spark as a service. So he's got real broad expertise, again, hands-on in both the technologies and the diverse sort of business cases into which these technologies are inserted, again, by organizations that are really trying to do more to improve customer experience or increase efficiency of distribution of product or whatever it is that we're all trying to do with data at different times for our business. So I'm really looking forward to his presentation. Again, I encourage you to ask him questions through the Ask a Question interactive feature of the webcast. And I think with that, Mike, I'm going to invite you to go ahead and get started.
Well, thank you very much for that introduction, Lenny. I think I'm going to bring you around everywhere I go to introduce me. You did a great job. Thanks. So the idea today is to go over, at least at a high level, what this NoSQL thing really is, what it's used for, and why should we really care. We're going to go over the characteristics and differences of many different NoSQL solutions, specifically highlighting the data and consistency models and the differences there. So first, I want to start and give credit where it's due. When I started, these two books were extremely, extremely helpful. The first is Martin Fowler's NoSQL Distilled. So essentially, this goes through the guide to this emerging technology, or emerging at the time. And then a more practical book is the 7 Databases in 7 Weeks. So this is by Redmond. So this is going to take you through 7 databases. So all NoSQL, Mongo, React, Neo4j, and 4 others. And essentially it gives you properties on all of them, characteristics on them, and you actually get some hands-on work. So it'll give you the code base and tell you to download some assignments and help you through those. So it's really great to get a starting feel for a bunch of different types of NoSQL databases. So here is 2 links, 2 YouTube links to videos of both Fowler and Redmond giving talks at various conferences. And again, really just talking about what some of the topics in their books and NoSQL, what the uses are, et cetera, et cetera. I very much suggest you go and watch those if you're interested. So we are going to start at the start. I'm going to give you a little bit of a history here of the databases. So back in the 1970s, this idea of a relational database management system popped up. It actually came and originated at IBM. And that lasted to about the 1990s, and still today, of course, they're extremely prominent, extremely profitable, useful, and all those great things. Then in the 90s, there's this thing called the ObjectDB. They threatened, but eventually lost to relational management systems. Then in the 2000s, we had the .com boom, and these two papers came out of Google and Amazon, which ended up having an extremely profound effect on the database community. Then in 2009, there was this NoSQL meetup in San Francisco. And in 2010 and beyond, there's this idea of polyglot persistence, which essentially means using the right tool for the right job. And of course, the rise of this thing called the cloud. Let's go into each spot, each time frame. So we'll start at the relational database. So again, like I mentioned, it originated at IBM or within IBM in 1970. Typically, you store data in tables, rows, and columns, or the records are in rows. Each table has a column designated as the primary key. And then there's these things called foreign keys, which can reference each other or reference primary keys, allowing for cross-table joins. So relational really dominated the scene because, well, they're great, right? They have well-known qualities. They're production-proven. They give you things like persistence and consistency and allow for transactions, massive amounts of integration, and you can do things like business intelligence and reporting on top of them. And this, by no means in this presentation am I trying to say that relational is going anywhere or NoSQL is better than relational. Relational is definitely here to stay, and I'm all for it. So next in the 90s came along these ObjectDBs. So really the promise was developer productivity. And the reason is, well, let's go back a bit. Even though the idea of object-oriented programming started as early as the 1960s or the 60s, object-oriented programming really developed as a dominant programming methodology in the early and mid-1990s, when programming languages supporting these techniques really became widely available, things like C++ and Java and all that fun stuff. There was this impedance mismatch, though. It was becoming very difficult and time-consuming to map all of these relational tables into an application object, which was the natural unit for developers, and still, very much is. All the needed information was decomposed or splattered across many relational tables. This meant multiple calls to the database and a lot of frustrating read, write, and update logic that programmers and developers just it was really more annoying to do than anything. Application architectures, especially at large enterprises, are still designed to use relational databases with these ORMs, or object relational mapping. And they're still designed to use these as the integration mechanism between all sorts of different applications, really to the point where people are becoming over-reliant on it, or did at least. So that means, at the time, object relational databases or object databases lost out. So then there was this .com boom, right? Everyone knows about that and what that entailed. Well, really, when it comes to databases, this really brought a lot of problems, right, to the relational database world. Problems like basic data access. Requests would hang while all these transactions were executing, and the system would lock down and release records because relational is essentially a consistent system. Issues like scaling up vertically, right? We'd have to get, when mobile applications or web applications got more popular and more popular, we'd have to scale our servers up vertically, which meant, bigger boxes, right? Which would also mean things like transferring the application from box 1 to box 2, or transferring data, or keeping things in sync, and all the problems and headaches that came. Then there was this idea of scaling out horizontally, so clustering or cluster technology. Well, then join operations on these tables that lived on different cluster nodes became very hard to do, or took way too long. And then there was issues like concurrency between our write master node and the read-only replicas. So essentially what happened was there was this database cluster, and sorry, let's advance the slide here. So what happened was Google and Amazon created these white papers, which were about distributed computing and distributed databases. So Google created this white paper, a distributed storage system for structured data, and that ended up being a thing called Google Bigtable, which then went on to become HBase. And then Amazon had Amazon's highly available key value store, which was now Amazon DynamoDB. So here are a few, since roughly 2008, here are a few of the databases that emerged. After those white papers came out and after they became open source projects, essentially everyone and their brother were at least a part of some sort of NoSQL startup, or at least so it seemed. So I want to discuss why I think NoSQL itself is a bad term. So it started as a hashtag for a meetup in 2009, and it actually was supposed to stand for not only SQL. So one of the reasons why I don't like it is because it's really defining something by what it's not, and it's a very loose definition. What it is an umbrella term for databases using non-SQL query languages. But essentially, there's a bunch of different flavors of NoSQL, right? There's the four main ones, which we're going to talk about today: the key value store, the column family store, the document store, and the graph store. Some also define these as non-relational or non-relational databases. But again, I also don't think that that's a great way of putting it because, well, one, it's still possible to represent relationships in NoSQL. And two, graph stores, a part of NoSQL, the NoSQL umbrella, are highly relational. They're even more relational than relational systems. They're only relationships. So going back to that image I showed earlier, here's how they group off, right? So there's the document stores like Mongo and Couch. There's column family stores like HBase and Cassandra, key value stores like Redis React, and graph stores as in Neo4j. There's obviously a lot more, a lot of them that are very tunable to be one or the other, but here's just a general feel. So actually, the marketing team at Cloudant came up with this nice navigating NoSQL map, as you would. So if you take a look at it, there are quite a bit of different flavors, like I mentioned, the four I mentioned before, and then there's the multi-model that can be changed to be one or the other. And it has a little bit of a key there that says, which ones are based in open source, which ones are database as a service or cloud enabled, and which are offered through IBM. So usually they share some sort of commonality, right? So what ties these NoSQL databases together? Well, one commonality is that a lot of them have their roots in the open source community and have been used and leveraged in an open source manner. And this has been absolutely fundamental for springboarding their growth in the industry. You'll often see companies who also provide a commercial version of the database and services and support of the technology. Many times I've gone to an enterprise engagement and they'll say, oh, no, absolutely, we can't just use open source, right? We have standards. So that's why they'd come to someone like IBM, who's offering this great, perfect, awesome open source technology, but we're also offering the services and support of that technology. And at the same time, providing sponsorship of the open source counterpart. So you'll find a lot of the times, well, let's do some examples first. So the examples include something like DataStax for Apache Cassandra, IBM Cloud for CouchDB, and Mongo has their own open source version of this. So oftentimes you'll find the company, so for example, IBM, we will have a lot of contributors to CouchDB, or DataStax will have a lot of the contributors to Apache Cassandra. Technically speaking, all of these databases differ quite a bit in terms of architecture, code base, all that fun stuff. But of course, like I mentioned, a few commonalities do emerge. Most NoSQL databases are built to horizontally scale and share their data more easily than their relational counterparts. And to do this, it often requires some sort of unique key across the whole database, something to shard upon. They also, NoSQL databases are also more specialized than relational systems, which have previously been considered like the Swiss Army knife, the one data store to rule them all type thing. But developers are drawn to these NoSQL solutions for the ease of data modeling and ease of use. Finally, many NoSQL databases allow much more agile development via these flexible schemas and these versus the fixed schemas of relational databases. There's no such thing as locking the table for a big schema change or things like that. No asking your DBA to if you're allowed to store this thing here. All that stuff that no one likes to do. So let's go in and talk about each individual group, let's call them. So we'll start with key value store. A key value store is essentially a hash map, but it's persisted to disk. Not technically all the time, but it's persisted to disk. These values are opaque. Typically, it's great for very fast reading and writing of data. Actually, it's typically very fast, but also very predictable. It's great for caching, so something that has like highly variable data values or high performance. And so, for example, if you want a mobile application, but you want to store some of the session data or some of the very hot data in memory and an in-memory cache, you can use something like Redis, which is a key value store. One of the setbacks of this is you can't normally query against the values, only on the keys. So again, this is great for something like storing user sessions. Next up is the document store. This is my personal favorite. This is the type that'll probably be most comfortable for people coming from relational and not really having any idea what NoSQL is. Essentially, it's a type of key value store where the value is much more clearly defined. So, for example, in this document here, what's the person's name? It's Zoe. What's the movie rating? Well, it's PG-13. What's the movie name? Avatar. It's very simple to read and write. Often in document stores, there's this primary index. In this case here, it's _ID. This is a CouchDB document. But there's some sort of primary index or shard key across the entire database. And there's always a secondary index. And you can index any other field. So if we want to start searching, give me all of the movie names that start with A, for example. We can do that here. And this is a great fit for modern web and mobile applications. You can store things like application state, what information is stored in my profile, what items are in my shopping cart, et cetera, et cetera. So there's a fuzzy line here, right? You might be thinking to yourself, well, the quality is the one and the quality is the other. They're pretty quick. I'm sorry, they're pretty similar. And that's true, right? You can use one as the other and vice versa. So I can use a key value store. I can tag some additional metadata at write time for secondary indexing. Or I can use a document store, and I can use that like a key value store by just only getting the primary ID or the primary index. So the takeaway of this slide is a lot of these databases, you can use as pretty much any of the 4 flavors, somewhat excluding graph database. It really just depends on the features and functionalities you're looking for. So here's a term coined by Fowler, Martin Fowler's term. It's aggregate-oriented databases. Essentially, the idea is the object is already stored in your application's memory, so it's much more efficient to store that in the DB in one go, or keep all of that data as one object and store it in the database. And anytime you need to retrieve it, you just go and ask for that big blob of data back, and then you can populate your object, your application object, in one go. There's no relational mapping needed. This, of course, promises this idea of developer productivity, right? You're only using one line of code where before you'd have to use 5 or 6 or 7, and it's just a lot less complex. So up next is column family stores. So what a column family store is, essentially it's a map of hash maps. The column names are of the form family : qualifier. These are great if you need high throughput on all of your writes with some sort of timestamp versioning. You get all the compression benefits of a columnar database, but without the schema limitations. So the columns might generally require the same data type for compression purposes or to see that great benefit. This places a little bit of additional constraints on your data model, but it's much more efficient if you're reading and writing all the way down a particular column. The column families there then becomes unit of aggregation. So a great use for this is something with sparse columns, sequential writes, so things like activity logs or analytics on variably structured data. And it's best when you have a lot of data. So, high hundreds of gigabytes, terabytes of data. However, these column family stores typically have a bit more configurations and schema planning up front. So some don't necessarily want to do all that configuration if you just don't have to, right? If you don't need the pros of this type of database, if you don't have a ton of data, maybe something like a document store or key value store makes more sense. So you don't have to do all that extra upfront work. Up next is what I'm going to call the odd man out. So this one is most different than the others. So graph stores are based on graph theory, the arc node topology, and all of the little dots are represented by nodes, all the entities, all the data, and they're connected by all these properties. Right? Sorry, they contain properties and they're connected by all these relationships, I'll say. You break data down into the smallest relationship possible, and it allows for better exploration of complex relationships. The reason why I say it's more relational than relational systems is because that's all it is relations, right? Person A knows person B, or person A knows person B who knows person C, so maybe person A should know person C. So this is great for things like recommendation engines. So something like Facebook, right? Or something like I just bought product A and product B from Amazon, so they're going to suggest to me product C based upon the millions of other people who have bought product A and product B. It's really optimized for jumping around, right? It has foreign key constraints, it has joins, and it has hierarchies that are really hard to relationally model. It has subject, verb, predicate, query syntax. So yeah, that's why I mentioned it's more relational than relational. So next we're going to talk about consistency models. This is probably the most important topic of NoSQL, mainly because a lot of the times they don't offer ACID compliance. So as soon as I say that to someone like a bank, they say, whoa, not a chance are we going to use something that's not ACID compliant. But then after talking with them, maybe for certain applications, you just don't need that hard consistency. So let's talk about that. So first, let's talk about what ACID is, or what ACID guarantees are. So it's an acronym, like most of us know. A stands for atomicity. So essentially, each transaction must be all or nothing. So if I send in a big bulk write of 1 million documents and one fails, well, they all fail, and none of them get persisted to disk. The C is for consistency. So constraints, foreign key constraints are always applied before data is written. The I is isolation. So this is sequencing. Sequencing of transactions is ensured. And D is durability. So committed transactions will survive errors such as power loss or database crashes. Basically, the idea is that no one comes into the middle of a transaction and messes it up or screws around with it or changes it or anything like that. Graph databases tend to be ACID compliant, but the other three, or the aggregate-oriented databases, they might be ACID at the individual document level, might be, but not really among multiple documents. And again, this isn't nearly as bad as it sounds, since documents tend to naturally aggregate themselves. All the data they need anyway are self-encompassed. So a lot of the times you can get away with eventual consistency models. And we're going to talk about that quite a bit in the next 4 or 5 slides. So when you talk about consistency, there is 2 types or 2 kinds of consistency. There's the logical consistency, which is the C from ACID. This is ensuring that no read, write, or update really gets in between another transaction. So this is enforced with the use of database locks. Then there's this replication consistency. As we mentioned before, NoSQL systems generally scale horizontally, if not all the time, and hold multiple copies of the data for many different reasons. And and replication consistency means that each copy of the data is the same. So here's an example. An airline, if you take an airline booking application, many businesses have built-in mechanisms for dealing with inconsistencies. Something like points or upgrades for bumping flights, or credits or things like that if it's an overbooked flight by accident. Or something like the Amazon shopping cart. It's a similar concept. How many times have you went and put something into your cart, went to the next page to pay for it, and something wasn't there? But if you hit the refresh button, it comes in. Right? It just takes a little bit of time for it to shake out that eventual consistency. It really all depends on your business rules, how much you can tolerate, but eventually consistent behavior isn't exactly a bad or new concept. So here is my favorite slide and something I bring up in almost every engagement. It is called the CAP theorem. Posited by Brewer, given there's a network partition, which will always happen in a distributed system or a clustered system, your system can choose to be either fully consistent or highly available. You can't have both, right? So like we said, NoSQL is typically partition tolerant, so it's choosing between the A and the C. So for example, something like Mongo claims to be C or consistent, and something like CouchDB claims to be A or highly available. There are some database companies out there that will claim to do both, like always, but they are liars. Do not believe them. That'll be breaking the theorem. And all that being said, in modern NoSQL systems, the reality is that it's a trade-off of much lesser extremes. Really, you're trading off between consistency and response time. Usually, you can tune the database for various consistency or response time settings. Let's talk about what eventual consistency is. So when thinking about this type of consistency versus response time trade-off, does all of your data everywhere really need to agree with each other? Well, probably not if you're doing it right or if you're architecting it correctly. So why not embrace it, right? Each node in a distributed system will eventually contain a consistent view of the data. We just have to ensure that our access patterns allow for that. And 99 times out of 100, you can usually make sure your access patterns are in such a way that you don't even notice the eventual consistency. So any eventually consistent system will have this thing called MVCC, or multi-version concurrency control. It's a database methodology for syncing changes between different copies of your data. So there's no locking. There's no idea of locking. Anytime I send in a read, it's going to be fulfilled, if, of course, the document's there. There's no idea of waiting in line or waiting in a queue so you can get the key for your database lock so you can go read something. So that being said, when should we use NoSQL and why should we really care? Well, the two biggest advantages I find are, one, easier development, especially when coupled with something that's a managed solution. So meaning something like a database as a service. So if you go to IBM and say you want Cloudant, that all comes, there's a bunch of different models you can consume that by, but let's talk about the cloud version. So you can come to IBM and you say, I want 3 nodes of Cloudant. Within an hour to a day, you have your cluster spun up and you're already developing. development against a NoSQL system usually comes very easy towards developers, specifically ones who like object-oriented methodology. So essentially, I just go and ask for my document, I get it back, it's already in an object, it's already in the JSON object, and from there, I'm off to the races. So developers have opened their hearts to this NoSQL idea because it's very, very agile. It's very easy to iterate process. There's no talking to your DBA and asking for certain permissions, this or that. Usually just off to the races developing. And then you also get all the advantages of a distributed system, right? You get the idea of a high concurrency data access. So we can have the millions and hundreds of millions of people accessing our system at the same time, which essentially is where and why it was born. And lots of data, right? You don't have to have a single monolithic machine that can store hundreds of terabytes of data, where you can have instead hundreds of machines handling these terabytes each and getting all the benefits that come with that. So why did NoSQL succeed when object databases failed? Well, now that everything, well, not everything, a lot of things are embedded into these web or microservices, applications now control the access to the data. And when you have the application in the palm of your hand and 100 million people across the world have that same application, you're going to need something that can handle that. If I had a nickel for every enterprise customer who developed this mobile application and it got popular and their SQL server crashed or didn't handle it, and I moved them over to some sort of NoSQL solution, well, I'd have a piggy bank full of nickels. Now, there's this idea of polyglot persistence, like I mentioned before. Applications can now use the right database tool for the job. A lot of different tools coming together to handle the job. There's fewer integration databases, whereas before they'd have the one massive relational box, which would handle the BI, which would handle the reporting, which would handle maybe some predictive analytics, would handle all the web and mobile traffic, and it just got to be too much. And now you don't have to have that. You can have a very fine-tuned, problem-specific tool to solve that problem. Also, the idea of the API, right? The API mentality. So most of these databases just sit behind an API. So it helps the application programmer and makes it a lot easier to interact and get data in and put data in and get data out. With that being said, I think I can pass it off to you, Lenny, and we can do some Q&A.
Let's do that. What a great overview you provided. Really, really appreciate how concisely you gave us a picture of that, and I think both for those of us who might be less familiar with the differences, as well as those of us who are more familiar with sort of some of these individual technologies, but you painted a good picture of how they all relate to each other. Do have some questions in already, and again, if you're on and you haven't submitted one yet, please go ahead and do so because we have plenty of time. So you did, during your discussion, Mike, you talked about the differences between some of these different flavors of NoSQL, or whatever we're going to call non-relational or not purely relational databases, in terms of functionality and appropriateness for use case. So I think I have three questions here that relate to that. One of them is that we're not always having a single use case. So I may have data stores for which I need to do some pretty cool impromptu analytics, whereas I also have some, large-scale, fast, real-time reporting or something going on. So does that mean I try to sort of split the difference and use the database that best meets both of those, or do I think about using the same data store and applying these sort of individually to each application? What's generally the approach? Do we tailor one to the other, or do we kind of make a decision about about using that, which best meets the most of our parameters we think we have. And then there's the ones, of course, that we can't predict, right? So we're making database decisions, and then 3 or 6 months later, the business is coming in and telling us about something we never contemplated. Can you give me some idea about how we map that problem?
Sure. So, I mean, this is an age-old question,
Yep.
I find. Essentially, I don't want to make it seem like each of these flavors handles, a single problem. So I want to make it seem like document, okay, that only handles web and mobile, because it can handle a lot more diverse portfolio of problems, right? So you just have to ensure that it is the right tool for the job, right? So not to say that you can't put multiple use cases on one of these databases, but I do very much recommend getting the right tool for the right job. Of course, within means, right? You don't want to have and be managing 50 different databases for your 50 different use cases. A lot of the times, you can give up, 1 or 2 exact match points just for the sake of keeping the same database, right? So that being said, a lot of times I do see, to your last point, that happen all the time, where I'll go and put in a cloud and cluster. I'll get a client up and running with their use case. They go and love that, and then 6 months later, they have a new use case, and they automatically say, well, we've got this bright, shiny new toy, so let's put it on CloudDB, and it kind of breaks everything, because it's just not it's not a NoSQL solution. It's not a NoSQL problem. It's a relational problem. So you just have to be careful and understand, understand the problem at its core, and then map it to the product, or map it to the technology.
Yep. And again, 2 more related questions. One of them is also in a business context. It's not just, you talk about sort of not having, trying to fit all of your round and triangular pegs into the same hole. So that's from sort of a functional and use case point of view. But we also have this issue of skill sets. So you talked about what's easy for developers to do or not do, but there's not a single uniform type of developer. Developers tend to have familiarity and skills with one versus the other. So whenever I do an implementation, I either have to acquire skills or have some learning go on. What's your sense in terms of where the developer population is, where skills are, and how my choices of a database might be influenced by either the skills I have in-house and or the ease with which I could onboard additional skills I might need for that particular technology, if that question makes sense to you?
Yeah, great question. So that happens a lot of the time. So I'll go into a meeting, and they'll present me with their problem, and I'll say, hey, have you thought of this NoSQL solution? And they'll say, well, we already have, a whole floor of SQL developers, which almost every enterprise company has, and we don't want to have to go and acquire new skills or have these guys learn something. And then I'll do maybe a day's worth of training to a few of them. And I've seen it where, I'll give this training, and a week later I'll come back and their whole application's already been mapped to NoSQL. Right? It's not nearly the learning curve as SQL is. There's no idea of there's no concept of page-long SQL queries and complex joins and things like that you have to master. The nice thing about I shouldn't be. This isn't an umbrella conversation. Sorry, this isn't an umbrella statement for all NoSQL solutions, but a lot of them are very, very simple to pick up and use. And it's very simple to map NoSQL to, SQL applications to NoSQL applications. One of my clients once said, I love this quote, he said, I love NoSQL, or specifically we're talking about CloudDB. I love CloudDB because you put data in, you get data out, and that's it, right? You just grab the data, it's already in an object, and you're off to the races. So a lot of the times it's only, it's a pretty small learning curve to get started, and I do recommend, just trying it at least, getting your hands dirty for a week or 2, and see if it catches on.
Yep. I don't know whether we've done any very intense developer demographic psychological studies to also see if a particular type of developer maps well to one versus the other, but I think we have some experience over time to find that, it really is sort of you innately need to have a very adaptive, learning-hungry developers because a lot of stuff's going to change anyway. So I think the old equations about mapping skills to technologies is starting to become less important than, hiring actually for adaptability inherently.
Right,
and I believe, go ahead. Yep.
I was going to say, I do believe that, colleges and universities are starting to put NoSQL into the curriculum, because people have kind of realized it's here to stay. The skills will be coming out straight out of college too. So, the formal education is going to be there, if not already.
Yep. I agree. Now, you mentioned it in passing, but I think it's also interesting to talk about not just capabilities, right, but also the way these different flavors affect performance for certain types of tasks and therefore the infrastructure that's required, which in turn leads to kind of the cost profile at scale. And I'm also assuming that organizations have different tolerances for this because, let's say, an older line company with a lot of technology debt and built-in costs might view the incremental cost of having to add infrastructure to do this stuff as kind of more of a pain point as opposed to a greenfield company that's like, okay, well, we're going to get all the capacity in the cloud we need, and that cost is going to be driven by whether our business is growing or not, right? So they will tend to look at the cost associated with application infrastructure differently than another company. Does that make sense? That part of what you want to think about when you're choosing these is how they're going to drive infrastructure cost at projected load?
Yeah, absolutely. So I'm going to tell two quick stories, and then I'm going to bring it back and tie it all together. So two real-life examples of performance versus infrastructure costs. Client one, essentially they had a massive data warehouse, and they loved it. They loved the technology. They loved how they used it. Everything was hunky dory, but it powered their web and mobile application. Definitely not what the data warehouse was for, but it worked at the time. Web and mobile application started getting very popular. And then they were looking into bringing in another of those big appliance boxes. And that came at a cost of something like $1.2 million, right? So they were taking a tool that wasn't necessarily used or should be used for this and bringing it in just because they are familiar with it and they liked it, right? So what we suggested to them was, hey, why don't you use something like CloudInt? We'll get your web and mobile traffic on there, and then we can sync all that data back down to your data warehouse if you need it, or vice versa. And you can let the data warehouse do what it's supposed to do, that higher order analytics and number crunching. Works great, worked awesome, they loved it. Client number two, they had their mobile application on SQL Server. And SQL Server was running perfect, but the performance, once it started getting popular, the performance of the SQL Server, even though it was strictly made for this web application and mobile application, the latency was spiking because the users were growing. So he said, they went to go and build that box bigger, upgrade the RAM, upgrade the CPUs, and that was extremely expensive because there's a hypothetical limitation to how high you can scale a box or how large you can scale a single box. And we offered them the cluster technology and explained all the benefits there. And they moved to cloud, and they loved it, right? So the idea of performance and infrastructure cost really depends on the use case. Typically, when you have this high concurrent, high workload, SQL is always going to be less performant. The reason being is it's a consistent system, right? So even though the actual single transaction might take 3 milliseconds, if there's 100,000 people at the same time who issued that transaction, they all have to wait in a line. So I just waited in line for 3 seconds, but my transaction only took 3 milliseconds.
Yep.
So that's the performance benefit of NoSQL. I mean, there's a lot of other ones, but that's the main one. And let's talk about infrastructure cost. So this is probably my favorite feature of NoSQL. So number one, they're all based on open source. So if you really wanted to be adventurous, you can go download the open source for free. Of course, a lot of enterprise customers are not okay with that because they need services and support. They need someone to go to if something goes wrong. So then they can come to someone like IBM who has things like Mongo and CouchDB and some sort of graph database, all that fun stuff. All the open source projects, but we serve and support that. And then also the fact that they're scalable, you essentially only pay for what you need. You start small. You can start at 3 nodes, which gives you, or even less, depending on the technology, which is a very small, cheap footprint. And then as you grow, you just add more nodes to the ring or add an extra cluster beside it, and you basically only pay for what you use. So that's another phenomenal advantage of NoSQL and cluster technologies, as opposed to having to go and buy that $1.2 million box up front, sit it down and wait for it to become of use and get your money's worth. You can pay for only what you need. And last point on this is a lot of these NoSQL technologies have a managed version, cloud-centric managed version. So essentially, all you're getting is an SLA and the keys to your database, and that's it. You don't have to worry. You don't have to hire the Linux admin to make sure that the kernel's up to date. You don't have to hire the infrastructure guy to replace the disk when it's broken. You don't have to hire the database administrator to ensure that your data is not the data volume is not filling up the disk. All that is covered by the vendor. So there's a lot of the TCO or total cost of ownership of these systems are drastically lower than most typical solutions.
Yeah, well, that leads us to another question we have here, which is about open source. So for some people, when they hear open source, they understand some of the advantages you talk about. They may have some concerns about security, also version stability, and they may have reliability concerns, again, because which features have been tested, by whom, according to what standards. Do you want to talk about any other aspects of the open source database market in terms of decisions
sure.
that corporate buyers are going to make and how they can make them?
Sure. So the biggest advantage of open source, in my mind, is you have a free development team, right? Mm-hmm. You have hundreds of people developing this project who are extremely passionate about it, adding features and functionalities that will eventually trickle down into your version, right? So that's the biggest advantage by far. The second advantage is this tends to lead to a lot of people using these because they are free, a lot of questions coming out, and a lot of questions being answered. So a lot of the times when you have an issue or running into an issue, a lot of the times you can just Google it and it'll bring you to something like Stack Overflow, and that answers, someone's already ran into that problem and that answer's there. So the documentation around these projects are, extremely useful, right? And extremely large. So that's great, right? And I understand security and stability are absolutely paramount to a lot of enterprise customers, and that's why I would suggest to them go find the vendor that's offering the services and support on top of, because 99 times out of 100 there is one. So you get the best of both worlds, right? Essentially, you get the people, because a lot of the contributors do work at the company, you get the people who are working on the product itself, and you get all the other people who aren't working on the product, this huge developer team, and you got to use something that's kind of tried and true. For the security, that's kind of up to the vendor to handle, right? I totally understand that there may be some security loopholes or security issues in these open source products, and that's up to the vendor to either patch or fix or handle, which a lot of them do, right? I mean, we're IBM here, so security is number one, always on our minds.
And you kind of have the same issue you do in terms of a lot of people being passionate about working on something, right? So you probably have a lot of people who are white hat cracking on the database as part of their.
Oh, absolutely.
Yeah,
absolutely. To be the guy who break a project is pretty great.
Yeah, you get a lot of status points out of it, so you've got people working on that too. And I think I want to ask you, we have a couple of questions relating to kind of where do I use NoSQL versus relational, what are some top use cases. I think you went over a lot of that during your presentation, but I still want to give you an opportunity. What would you say are kind of the main takeaways in terms of the type of project or use case I may have in front of me right now or maybe coming right down the pipe where I might have some triggers, some specific triggers that'll make me think, you know what, this is probably the place where I'm going to try using something that's not my traditional relational database that I've been using for the past 15 years or whatever. What do you think are some of the key trigger points for that?
Sure, that's a great question. So the rule of thumb, or the number one use case I always see and always try to push towards NoSQL is what we call a system of engagement.
Mm-hmm.
So what that means is if I have a lot of people using my application or a lot of people accessing my database or data from my database, that's when NoSQL is really going to shine. So think web, think mobile apps, right? That's the best solution for it. But not only web and mobile apps, so sometimes internal applications. So there are large companies out there. Think of IBM. We have 400,000 employees, right? So having these internal applications housed by NoSQL, you can get a lot of people using them at the same time and have a great user experience. So that's a good use case. Another good use case is when you want to distribute data, right? Mm-hmm. So have it geographically distributed. So a lot of clustering technologies offer pretty robust replication features. So a lot of our clients of CloudInter or CouchDB use this for that exact reason. We have an office in US West, we have an office US East, we have an office in London, and we have an office in Australia, right? And we want to keep these databases, not only do we want the people using them to have great user experience with low latency, we want to keep all the data in sync, right? Mm-hmm. You can do that, right? You can have a cluster in each area, replicate the pieces of data that can be moved around, and have those users only hitting the cluster that's closest to them. So it keeps up that nice user experience and moves data where it needs to be with relative ease.
Great. I think that was a good way to. Yep. Go ahead.
I was going to say, so those are the things you want to be on NoSQL. A few things you don't necessarily want to be on NoSQL.
Good. Yeah, share that too.
Yeah, so any sort of higher order analytics, most NoSQL have some sort of analytics built in, some sort of querying mechanism. But, the real, statistical modeling or some sort of, regression algorithms, things like that, those are typically things not necessarily suited for NoSQL. Not that they can't do them or can't have plugins to get those done, but typically something you want to stay away from.
Great. And I think that's it for the questions. If we didn't get to your question or if you still want to submit one, we can get to it offline. We are getting near the top of the hour. So Mike, I just wanted to give you one more opportunity before I wrap up. If there's any final word, anything you want to share with anybody, feel free to do so. I know that you told us about some reading before. Don't know if there's anything else, last bits of advice you want to give our attendees today.
So on the last slide there, you can see my email address. If you have any questions about any kind of technology or just want to talk nerd, feel free to shoot me an email at any time. There is a great course, Introduction to NoSQL and Database as a Service at Big Data University. That's a great place of learning, a lot of technological things, but specifically NoSQL we have there. I do suggest going on there. A lot of the database as a service have some sort of free version or some free or metered freemium version. So don't be afraid to go and try this. And even going one step further, these database as a service are great for POCs, right? If you have to convince someone, some line of business in your company, no, this is the tool to use. Because a lot of them are, pay as you go, month by month type things, no infrastructure needed on, in-house. You could do a POC and, have this cluster spun up in a day, be a single tenant, get all the performance tuning you need, and then if worst comes to worst, doesn't make sense for you guys, you hate it, you can just decommission it, and only pay for that single month. So doing POCs, POTs, looking into these technologies are typically very, very easy to do, and I do suggest doing that. And one more point to leave you with. NoSQL is here to stay. It's a great technology. There's immense value in it. It's not the answer to everything, like I mentioned. Relational is also still here to stay, but they can work in harmony. You can get that user experience way up. You can keep customers happy, and ultimately that's the whole goal of this. So embrace eventual consistency, embrace NoSQL, and if you ever need help, give me a call.
Wow, Mike, we really, really appreciate the hour you spent with us, and I hope people do take advantage of that. I'm pretty sure I will. And with that, I'll thank everybody for spending this hour with us. Let you know that you're going to receive a link for this presentation on demand. So like Mike was saying, if you have to share some information with a peer, maybe there's somebody you report to and you think this would be useful for them to see it, or people who report to you that you want to share this knowledge with, please feel free to do that. We do value your feedback, so please take the time to share feedback about your experience today so we can keep improving the quality of the programs we bring to you. And also, if you found this time with us valuable today, take a look at our calendar of upcoming events. We may have some more stuff in this area that's going to be useful to you. So on behalf of Mike and myself, again, Lenny Liebman, who's been your moderator today, appreciate your time. Get your feet wet with this stuff, and have a great day.